Let's go ahead and finish up this graph on the bottom of page 5. Do you have an idea what's going to happen? That the two lines are going to cross where? Right here, right? So we can find the points of intersection using algebra, which we'll learn later in the module, by making t-tables and trying to find a common point, or by graphing the two lines and trying to find a common point. So let's go ahead and graph the friend line. So I labeled this one mean. Notice I didn't draw arrows that way because I can't have negative cost. I didn't draw arrows that way because I can't have negative cost. So the costs have to stay positive, which means they need to be in quadrant 1. So make sure you don't have any arrows or you don't go past the quadrants. Okay, so the next line, which is my friend's line, is 50 to 50. So 50 to 50 would be right here. And next we have $1.25. So $1.225 would be right here. $1.52 would be right here. And $2, $1.75. $2. There's $1.50, so $1.75 is the next line. And again, you know it's going to be linear, so make sure your points look straight. That's a good way to check for an error. 250, 150, ding, 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 ding. And then I always tell everybody, once you find the point of intersection, circle it and label it. So it's the point 250 for the cost of a hot dog, $1.50 for the cost of chips. So this is dollars for the hot dog. This is dollars for the chips. And then continuing on, we have 3 and $1.25, which would be right here. So again, we need to make sure that we go from axis to axis, but not pass up the axes. So there would be our very beautiful graph. And it would end here and end here. And this would be my friend. So I can tell by graphing all the different scenarios, the one in common is this, X being the price of the hot dog, Y being the price of the chips. Therefore, I know my solution is $2.50, $1.50. So I just figured out the cost without anyone telling me. Okay, so let's go ahead and go to page 6. Oh, yikes, my pen went through. So I guess we need to keep the graph here because it's asking some questions. So interpret what the intersection point represents on the graph. So we already did that, right? The intersection point represents that each hot dog will cost $2.50 and each bag of chips $1.50. So the intersection point, which is the point in common, point represents that the cost of one hot dog is $2.50, comma, and the cost of a bag of chips is $1.50, period. So subtract the equation of your friend's purchase from yours. Okay, so my equation, so from mine, does everybody understand from means mine's first? So 2x plus 2y equals 8. And this is kind of leading you into what we're going to do, like I said, at the end. So it's just kind of a little fun exercise. And we're subtracting my friend's equation, which was x plus 2y, I should have put that in red, x plus 2y equals 550. X plus 2y equals 550. So the reason I put parentheses is because you can't just change the sign of x. You have to change every single sign. So this first one would be 2x minus 1x. So when I subtract them, I get 1x, which is just x, right? So 2x minus 1x is 1x or x. 2y minus 2y is 0. Ooh, interesting, huh? So 2y minus 2y is 0. 8 minus $5.50 would be what, 250? So that means x equals $2.50. Is that what we got before? Yes, it is. So now you know 3 ways to solve an equation. So solve a system by making tables for both, finding a point in common. Solve a system by graphing both lines, finding the point in common, or we're going to learn add or subtract 2 equations, solve for whatever's left, and that's another way using algebra. This is the exact way. The table, sometimes you could have to do millions of points. Graphs are never exact. This is exact science. So this is what we're going to learn at the end of the course. So let's see what it says. Subtract the equation we did. From the information you have, determine how much a bag of chips costs and how much a hot dog costs. So X we know is a hot dog. So we'll write cost of a hot dog. So how do you think we'll find the cost of chips? We know what X is, right? So guess what? We can put it into either equation and solve for y. So let's put it in this one. So x is 250. So that turns into 1 times 250, which is 250, plus 2y equals 550. And we're going to learn later this method is called the addition method. So once you find one variable, you plug it into either this equation or this equation and solve for the other. So subtract 250, subtract 250. 2y equals $3. So y is $1.50. Exactly what we got here. $1.50 for what? Chips. For a bag of chips. And there we have it. Exact same answers we got before. So now we know 3 ways. Making a table, making a graph, and like I said later, we're going to learn this is called the addition method. So the addition method will also help us find the point in common. And we're going to study that a lot. We have a whole section just on that, or maybe 2 sections at the end. Okay, let's go ahead and move on to page 7. I like this problem. If I was giving you a paper pencil test, I would definitely put this problem on it. So let's get bigger here. And let me get my papers organized. Oh, I wonder if we answered all the, how do these 2 values, oh, okay. So here we are. What is it worth now? Page 7. A small business buys a laptop for $1,000. After 4 years, so let's underline that. After 4 years, the value of the laptop is expected to be $200. So 4 years, $200. For accounting purposes, the Business uses linear depreciation. In other words, that's just telling us y equals mx plus b. Depreciation, though, does tell us our slope will be negative because the value is going down. So slope is negative. So based on what we've read so far, who can tell me what b is, the starting point? 1,000, right? Isn't that what the laptop started at? Its value was 1,000, so there's our B. So look at that. We already know our B. We already know our slope is negative. Okay, this means that B is the value of the laptop as a function of time, t in years. So this is my Y, and this is my X. And again, you always know by uppercase, lowercase, but also by as a function of time. That means time is going to be in parentheses, so that means it's my X. Determine the rate of change. Well, before I can determine the rate of change, I have to be able to have 2 points. So can you come up with a point? What would this point be? How old is a laptop when I buy it? 0 years old? $1,000? Everybody agree? That's the first point. So 0 years old, it's worth $1,000. How did I know to do that? Because I looked at this sentence. 4 years, $200. So I was thinking, what year do I need to put with 1,000? Oh, it's brand new. So the second point, and remember, time is always your X. I don't want to say always, but almost always. 4, 200. So now we can easily find rate of change using all the methods we've used in the past. So let's represent our variables first, because I like to have them all written out there. I don't think there's a question for that, so let's do that. So our X value we said is t, so t equals time in years. And our Y is V equals value of laptop in dollars. So notice I have my units with both of them. The first one's units are years. The second one's units are dollars. That way, when I go to do my Y per X, I go dollars per year because we use the units to do our Y per X. Okay, so rate of change is going to be second Y 200 minus the first Y 1,000 over second X 4 minus the first X 0. So what is that? Negative 800 over 4. Whoops, positive 4, Norris. And there's our negative slope that we predicted. So negative 800 divided by 4. It's rate of change, so it does need to be labeled Y per X. So let's just write that up there. You can never write it enough. The more you write it, the more it will just pop into your memory when you're taking a test or a quiz. So dollars per year. So dollars per year. So could you all write a sentence about that? The laptop's value is decreasing or depreciating by $200 per year. So let's go ahead and write that. What's the practical meaning of slope? The laptop's value is decreasing by $200 per year. So it's always what's happening to the Y. So the Y is the value. So the value of the laptop, the negative tells me decreasing by $200 per year. So that's the practical meaning of slope, what that negative 200 represents. Write a linear function. Okay, so to write a function, we need to have a y-intercept and we need to have a slope. So I'm saying we have a slope. This is our m, right? Do we have a y-intercept? I'm looking for a